Our Heavenly Father, our loving God, we thank you for this entire day. We thank you for the lives of our friends, our parents, our teachers. We thank you that you're our time. Father, we hand over this Zoom lesson. We hand over this hands. You, the protector of all. May you you enable our teacher and use him as a vessel message that you want us to learn through this lesson. May everyone who has attended understand what we are going to share, and may we all be able to contribute in a humble way and understand. We thank you for the work that our teacher is doing. May you bless him abundantly and we all benefit from it. In Jesus' name, I believe and
Amen. Amen. Thank you, Esther.
we're waiting.
All right. Please tap that registration link and register for attendance of this lesson. Fill that form for registration as an A-level student, strictly for A-level. Okay, please use that form to register. I'm going to drop it the second time if I concentrate on the lesson. All right, thank you. All right. As far as roots of a quadratic equation are concerned, Nachigo's Esther comes from Iganga SS. She has led us through this opening prayer, and she takes over the mantle to bless this session. Thank you so much, representative from Iganga SS. Our session today is a continuation on roots of a quadratic equation. I want us to be able to conclude this. If you do agree, we have looked at a variety of sessions in line with this concept, and we developed quadratics from the ground, from the grassroots, as simple as solving, factorizing, completing squares, and we developed it to the level of trying to play around with the roots. I want to believe that no one bears any problem with it. Want to proceed to problems in line with proofs. I want to proceed to problems in line with the proofs if there is no any other concern. If you barely have one, please let me know before we proceed to cases involving proofs. Before we proceed to cases involving proving. Okay. I see Ignatius Ryan is hand up. You can unmute. I hear from you.
All right, thank you, teacher. The other time he left us with some questions. He had given us a sample of about 4 questions and did part A and part B. We were left with part C and part D. I personally tried out C, but I failed to do D. So our request for
We were expressing in terms of the sum and product of roots, right? So what was part C? Remind us. What was part C?
part C was 1 out of alpha cubed beta plus 1 out of beta cubed alpha.
1 out of alpha beta cubed. To express this into
And then
sum
part
and
D.
product,
Yeah.
to start with, can someone take us through this one for the start, so that we pick up immediately? Yes, Diane, can you unmute? Diane, we can't hear you. Okay, it's unfortunate. We can't hear what she's saying. Any other person who did that part C? Yes, Ryan.
All right, let me give what I tried out. So I made the LCM as alpha cubed beta.
Alpha cubed
Beta
multiplied
everything.
by
Alpha cubed beta then times beta cubed alpha everything brackets.
if you are to obtain the LCM of this alpha cubed beta, it's multiplied by alpha beta cubed. When you try to get the LCM of this, we have alpha here, which will give us alpha beta, gives us alpha squared, and here it gives us beta squared. So alpha squared gives us a 1 here. Alpha squared now will give us a 1, and beta squared, then beta squared gives us a 1, 1. You realize that alpha beta times alpha squared times beta squared would imply the LCM is alpha cubed, beta cubed. The LCM is simple alpha cubed, beta cubed. Have you got that?
Right. Yes, teacher.
If I do a derivation, this is what you would see. Okay. So that leaves us with that.
So the numerator, when you divide alpha cubed beta cubed by alpha cubed beta,
by alpha cubed beta, we get beta squared, not so?
yes.
Then
Teacher,
alpha cubed beta cubed, divide it by alpha beta cubed, you get what? You get beta cubed, go and you get alpha squared. Are you there? Are we good at that point, members? Please reply. Ryan, where are you lost? Switch on your mic and talk to me. Okay, someone says, I pardon now I got the LCM. The simplest, the usual way we get the LCM is the way you would get this LCM. Alpha cubed, beta is one term. The other term is alpha beta cubed. So our purpose here is to divide. I can start with the alpha, and this will give me alpha squared beta cubed. I realize I have a alpha squared waiting. I clear it, I get beta and beta cubed. Then I divide all through by beta. This will be 1, and this will be beta squared. And lastly, by beta squared, this will be 1, 1. Now that shows us purpose when obtaining the LCM is to achieve a 1, a row of 1s. So when you multiply this one times that, alpha times alpha squared times beta squared, I get alpha cubed times beta cubed, which leaves me with that as my answer. This as the LCM. Please reply in the chat if it's now home, how we reach the LCM. Someone is okay. What about the others? Okay, Nakacho is fine. Someone taking no as the name is okay. Eric is also fine. Yes, good. That's good. That's good. That's good. So that means that the LCM here is alpha cubed beta cubed. So when you divide that alpha cubed beta cubed, when you divide it with alpha cubed beta, the alpha cubed cancels and you get beta squared. Plus, when you get that alpha cubed beta cubed and you divide it by alpha beta cubed, the beta cubed cancels and you get alpha squared. So resultantly, I get alpha squared plus beta squared over alpha beta all cubed. And we know that that top is the same as alpha plus beta all squared minus 2 alpha beta all divided by alpha beta all cubed. As the statement, 1 out of alpha cubed beta plus 1 out of alpha beta cubed in that regard. Understood? We have expressed it into the product and sum. Is that okay? Are we good at that point? All right. Okay, thank you for the feedback. Part D, yes, Ryan, give us part D. You are telling us part D was where you had issues. Part D, put up your hand, and I allow you to unmute.
Yeah, but it required us to express root alpha plus root beta.
Part D was root alpha plus root beta, expressing it into the sum and the product. Anyone there that handled that? Please put up your hand. You share with your friends. Anyone who did that? Yes, Joyce. Yes, Kato. Can you unmute? All right.
I think the square root alpha and square root beta, we say alpha power half, the power half, then we put into brackets, we power the whole thing a half.
We say alpha to the power half plus beta to the power half.
Then we put alpha beta half, so alpha plus beta into brackets power half.
Like that?
No, like another step.
Oh, we multiply it 2 times. So what you're trying to say is that we recall the square root of alpha plus the square root of beta all squared. Is it what you're saying?
No, I mean like square root alpha is the same as alpha power half.
Do you want us to write something like this?
No. I don't know how I can explain it, but I have alpha power half plus beta.
Alpha power half plus beta
Plus beta
half
power half.
into
Then down.
I say over.
Over
that?
Yeah. No, like I first worked out the sum alone and the product alone.
You tell me. Plus beta to power half.
Then the next step, alpha plus beta bracket power half.
Like this.
Yes.
From here.
Yeah, power half. That was my sum.
Oh, the two can't be equal. This power can't just go off like that. Yes, Carol. Let's hear from other people and we see. Yes, Carol.
My opinion was that the root of alpha plus the root of beta is equal to alpha to power a half plus beta to power a half. We know that alpha to power a half is the same as alpha to power -2. So it's going to be alpha to power -2 plus beta to power -2.
Two a half is the same as 2 power -1. That's what I know. Plus beta to power 2 power -1. That's what you would write. You see that?
Okay, sir. I'm getting it.
Now, the expected thing would be, maybe let me have one more opinion before I proceed. Diane. But you hope today your mic is working. Diane, your mic is not on. It's not okay. Now, this is what we would expect. For someone to get this, you would recall. You'd first of all recall the square root of alpha plus the square root of beta all squared, which is actually the root of alpha plus the root of beta multiplied by the same quantity root alpha plus root beta. Do you see that? Do we agree with that? So, okay, that's okay. Then expand it. Expand it. That will be root alpha into root alpha plus root beta plus root beta into root alpha plus root beta. Then when you expand it, what will you obtain? So when you expand that, yes, Eric. Okay. Now root alpha times root alpha will give me alpha if we do agree. Then root alpha times root beta is the same as root alpha beta, and this quantity is also the same as root alpha beta plus beta there. Root beta times root beta is beta. So now this is alpha plus beta plus 2 the root of alpha beta. So I end up with root alpha here plus root beta all squared, which implies that if somebody took a square root of both sides, that implies that root alpha plus root beta is the same as the square root of alpha plus beta plus 2 the square root of alpha beta. And I would have expressed it into the sum and product. Any question? Yes, Esther.
Sir, excuse me, sir.
Yes, please.
I have understood all the steps up to this answer, but why did we square in the first place? Like the question was simply alpha, like the square root of alpha plus.
Yeah, it helps us to generate the required equation. Just like normally, this is what is asked. They ask for alpha squared plus beta squared, but we leave it aside and we first recall alpha plus beta all squared. You get my point? Which actually brings us to what we want. You get the point?
Okay.
So alpha plus beta all squared, bring this minus 2 alpha beta, which is equal to alpha squared plus beta squared. Understood?
Yes.
All right, thank you. Are we all fine? I want to consider that done, unless if there is any other question.
So,
okay, if that is okay. Now, if there is no question on that, let's do other examples there. Let's do other examples, and under other examples, I want us to deal with the relations in proofs.
other example. Managua. Point.
So,
And
okay, someone's mic is on. That is Esther. Right. Okay, yes, John. Can I unmute?
Me, I have not understood on the step 2.
Step 2 of what?
What?
Step
Of
2 of
finding
what?
the of alpha beta plus alpha. Can't you simplify it on the step here? No, the first example.
Which example? Part C.
Yeah. Yeah. There.
Which example?
Can't you simplify it? Here. Where you have put the red box.
You wanted to simplify it beyond that step. Pardon?
Okay. I have understood it.
Okay.
Okay, it's okay.
All right. I want us to look at cases involving proofs. For example, this one here. For example, that one. Prove that if the difference between the roots of a quadratic equation is 1, then this is true. So in such a problem, I would expect one to start by letting the roots, let the roots be alpha and beta. Then the sum of those roots will still be negative b over a, and the product of those roots will still be a c over a. That is equation 1 and equation 2. Now they are saying if the difference between the roots, difference means when you subtract one from the other is 1, then you prove what is given. Yes, Arnold. Yes, Arnold.
Sir, good evening.
Good evening. How are you?
Sir, I am new here, but I'm not understanding why that negative was on that negative b out of a.
We proved this side, yeah. We did those things when you were not here.
Okay, I will research.
Yeah, sum of roots is negative for any quadratic equation in the form ax squared plus bx plus c equal to 0. The sum is negative b over a, then this product is c over a. We had that lesson in which we derived those details. So whoever I'm handling this lesson with, I assume didn't miss my introduction lessons.
Okay.
Please find out. So to prove this statement here, this is what they want us to get, class. To obtain that, they just want you to use these 3 equations and eliminate alpha and beta. So preferably, I'm going to use 1 and 2 using equation 1 and 2. Using equation 1 and 3. 1 and 3. I'm going to obtain alpha and beta. Alpha plus beta is negative b over a. Alpha minus beta is c over a. Now, when you add beta cancels, I get to alpha as this side. When you add this, you get c over a minus b over a. That means alpha alone will be a half into c minus b over a, if someone does agree. There's a simple problem here. You realize that this difference is 1, not c over a. That difference is 1. Sorry. So when I add beta cancels, I get to alpha. On adding, this will be 1 minus b over a, negative b over a plus 1. So alpha alone will be a half into a minus b over a. That is alpha. So on the same note, if you obtain the beta, beta is when you subtract these equations instead, you get 2 beta. When you subtract alpha minus alpha, this minus that, then negative b over a minus 1. You realize that beta alone, upon subtracting, beta will be negative b minus a over a, but the whole quantity is multiplied by a half, which someone can actually write as a negative a half into a plus b over a as beta. But from equation 2, we have alpha times beta as c over a. Do we all agree with my value of beta and alpha? The value of beta and alpha? Do we agree with the value of beta and alpha there? Are those fine? Okay, Vivian, please unmute.
Writing beta equals b out of a minus 1. I really can't get it. Where are we getting it?
Which one? The one for beta. Someone has not got it. Obtaining beta, I still get equation 1 and 3 and subtract them. Alpha plus beta is negative b over a. Then alpha minus beta is 1. When you subtract, alpha cancels and you get 2 beta as negative b over a minus 1.
Then that one of 2 beta equals negative.
It's what I'm showing. This is statement. Have you got it now? Okay, that person has got it. So I'm now going to substitute the alpha and the beta I've got in equation 2. This quantity, this alpha here, and this beta, I'm now putting them in equation 2 here. So what will it become? So alpha is a half into a minus b over a multiplied by beta, which is negative 1/2 E2. So 1/2 times negative 1/2 is a negative 1/4. Then A minus B multiplied by A plus B over A times A, which is A squared, which is equal to C over A. So this is negative 1/4 into A squared minus B squared, that's the difference of two squares, over A squared is equal to C over A. You see that? So this is B squared minus A squared over 4A squared, which is equal to C out of A. So A cancels, and then you get B squared minus A squared equal to 4AC. A squared has just reduced this A to A. So then when you make B squared the subject, you get A squared plus 4AC. A squared. So A squared is actually B squared. This comes this side and this way, minus 4AC. You see that? Do you see that? That's the required proof. That's how we have been able to arrive there. Yes, Ryan, ask.
So please help me from this last step on
Of cross multiply.
this one of negative 1/4, how it comes to go to this one of B squared minus A squared.
Enter the negative. Enter -1. -1 times A squared, you get negative A squared. -1 times negative B squared, it becomes a positive B squared. I've just entered that negative into each term there. It multiplied the numerator. Have you seen that? And is it okay? Prove that if one root of the equation x squared prove that if one root of that equation is twice the other, then 2b squared is equal to 9sc. If you've checked that one, the other one, it's okay. Let's go to this. We want to show that Yes, Morgan. Talk to me. Yes, Morgan.
Teacher, I don't understand. Okay, the question. Prove that the difference between roots of the equation this. So
You
they
are talking about the one whose solution we have finished.
yes.
Where were you when we were starting it? Look at this one, it's the same style. Look at this one I've just shared. Prove that, you read it keenly this time before I start. Prove that if one root of the equation is twice the other, then they want you to prove that this is true. Obtain this if one root is twice the other. So if the roots, you start by supposing the roots. If the roots are alpha and beta, if the roots are alpha and beta, what will be their sum? If the roots are alpha and beta, their sum is negative b over a, and their product is c out of a. If one root is twice the other, who can tell us how we can write that equation mathematically? One root is twice the other. Can you relate it to alpha and beta, that statement? Yes, Arnold.
Me, I would say that maybe alpha is equal to beta.
Correct. Or that one is okay. Or
I could say beta is equal to alpha.
Beta is equal to alpha, correct? Members, have we got it? Please reply in the chat. I'm listening, I'm trying to follow closely. Have we got that statement? One root is twice the other. Now we are going to use that condition. Thank you for that feedback. We are going to use that condition into equation 1 and equation 2. So what will equation 1 become? If I substitute, I'm going to use this first statement. You can use any of the two. I'm ignoring that first one, so I'm using this one as my equation 3. You can use any, remember. So feed it in equation 1. Where there is alpha, put 2 beta. So I'll get 2 beta plus beta equal to negative b over a. Yes, Jovita, complete. You have a question? Unmute.
Sure. Good evening, sir.
Please ask. You ask.
For me, I was saying, if the roots can we say if let the roots be alpha and 2 alpha.
It is also okay. Then you would have gone directly to the fact that one root is twice the other. It is also okay.
Yes.
So 2 beta plus beta, that is 3 beta. So beta is equal to negative b over 3a. Now, alpha is twice beta. So 2 times beta is negative b over 3a, which becomes negative 2b over 3a as alpha. Are we there? So the alpha and the beta I've got, I'm going to substitute them in equation 2. So now alpha and beta, alpha beta is C over A right? We agree with that point. So 2b squared is equal to 9sc at that level. I don't know whether we agree. I'm looking at the chart to see whether people are following closely. After multiplying the steps I've made, I've tried to be elaborative and be very clear on what I'm writing there. Upon substituting for alpha and beta, alpha as negative 2b over 3a and the alpha and beta as negative b over 3a. Is it okay? Please get back to me in the chat. Have we followed those steps? Good. I'm giving one for everyone to try it out and we brainstorm. Okay, there we are. Prove that if the sum of the squares of the roots of that equation is one, then show that b squared is equal to 2sc plus s squared. Everyone, you have let me say we have 5 minutes. Use 5 minutes to go through that problem. Let me hear from Nachigos Esther. Can you unmute? I clear your question as people attempt.
Okay, Sam. For me, what I've done, according to our equation, ax squared plus bx plus c, our sum will be negative b out of a. So I first of all let the roots be alpha and beta. Let the roots be alpha and beta. So the sum of alpha and beta, that means alpha plus beta is equals to negative b out of a. Then alpha times beta is equals to c out of a. Then they told us that the squares of the roots of the equation, that is 1. That means alpha squared plus beta squared is equals to 1. Is equals to 1 because their square is equals to 1. Then solving x squared plus beta squared, it gives me plus beta, the whole bracket squared.
So you solved which one?
Alpha squared plus beta squared. It will give me alpha plus beta squared, the whole thing squared. Okay, like alpha plus beta, the whole thing squared, minus 2 alpha beta is equals to 1. Alpha plus beta, I put there negative b out of a, where alpha times beta, I put there c minus 2 into c out of a. Yes, equals to 1. Then I squared, that gave you beta squared out of squared minus 2c out of a, just a, is equals to 1. So the square root there is a squared.
Square root or LCM?
The LCM, sorry, the LCM is a squared. So that will be b squared minus 2ac is equals to 1. Then b squared minus 2ac is equals to a squared. 2ac is equals to, therefore my b squared is equals to 2c plus a squared.
As required. Okay, thank you, Esther. That was a commendable one. Thank you, Esther. Thank you. Arnold Mwebaze, what's your problem? Your hand is up. Can you unmute?
Sir, there she had alpha squared plus beta squared is equal to 1. That next step, I don't know how she got that alpha plus beta, all of it squared, then minus 2 alpha beta
This
squared.
one.
Yeah.
You have not yet looked at Pascal. Which you have just started, you person, because we did these things. You recall that from alpha square, alpha plus beta all squared. Do you agree that this is alpha squared plus 2 alpha beta plus beta squared?
Yes.
Then you make this the subject. These ones have circled the subject. Alpha squared plus beta squared means this will go the other side to have alpha plus beta all squared minus 2 alpha beta. You see that?
Yes, thank you. I've seen it.
Right. Okay, back here. Yes, Patricia, Esther, what's your challenge?
Oh, it's not. I was just asking, are we going to get this recording after this?
Yes, the recording will be in your groups, please. It will be there. Okay, our next question is that the roots of the equation x squared minus px plus 8 is equal to 0. The roots are alpha and alpha plus 2. Find the two possible values of p. Find the two possible values of p. You have 5 minutes. Everyone try it out. Then I'll be waiting for the first hand to take us through.
Hello? Hello?
Yes, I can hear you. We can hear you. We can hear you.
All right, for our solution, they asked us that the roots of the equation x squared minus px plus 8 is equal to 0 are alpha and alpha plus 2. Find two possible values of p. So from our roots, we can get the sum, which will be alpha plus 2, giving us negative p.
Are you sure?
Giving
The
us
sum is supposed to be negative b over a. So our b is negative p, our a is 1. Will it be negative p or positive p?
is p.
It's positive p. Mhm.
And then our product
Mm.
will be alpha into alpha plus 2, giving us 8.
Okay.
So from there, we can use our, Shami had made a mistake.
Anyone who moved beyond that stage to us to proceed? Yes, Arnold.
So me, so when I reach there, I use that second equation, that one of alpha, that one of alpha times alpha plus 2 is equal to 8. First, I first remove the brackets, and I've got alpha squared plus 2 alpha is equal to 8. Then after getting that one, I formed a quadratic equation by bringing 8 to this end.
Okay, you had?
So I had alpha squared plus 2 alpha minus 8 is equal to 0. Then I used I used my calculator and I got the values of alpha, but I think which wasn't correct.
Factors of negative 8 that give us a 2, a 4, and a 2 when 2 is negative, not so?
Yes.
So by factorization, you would have alpha squared plus 4 alpha minus 2 alpha minus 8 equal to 0. Taking out alpha here, you get alpha plus 4 minus 2 into alpha plus 4
yes,
equal to 0, which runs us to alpha minus 2 into alpha plus 4, giving us a 0. So you round it to alpha equal to 2 and the alpha equal to negative 4. Is it so?
Yes. Then after getting the values of alpha, I substituted them in the other first equation I had.
So this implies P is 2 alpha plus 2, not so?
Yes.
So when alpha is 2, what will you get as P?
When alpha is 2, we substituting 2 in our equation.
When alpha is equal to 2, what will be P?
P will be equal to 2 times 2.
2 into 2 plus 2.
Plus 2.
Which is
which will give us The 6. Yeah.
What
Then
about when alpha is -4? What will be the value of P? 2 into -4 plus 2 is equal to
-6.
-6. So the values of P are 6. Therefore, P is equal to 6, or P is equal to -6. Not so?
Yes.
Is it okay? Is it okay?
Yes.
Anyone who didn't get that result, you need to look at that working keenly. All right. So next. So using the same idea, take off a few minutes everyone and try that one. We are finalizing roots of a quadratic equation, and we should be preparing to do something else. Look at that one. Everyone try it out.
Hello, good evening.
Good evening, Patricia.
Okay, my solution is that we get the sum of the roots given. So that will be alpha plus alpha minus 1, giving us a -6, the sum.
Correct.
-6. Then we get the product of, that is equation 1. Then product of the roots, alpha times alpha minus 1 gives us Q. Equation 2. Then from equation 1, we can get the value of alpha. Because when we open the bracket, we get 2 alpha minus 1 is equals to -6. We take -1 to the right-hand side, becomes -6 plus 1, which will be -5, divided by 2. Then we start in equation 2. Alpha squared minus
Yes, Patricia, continue. What should I write?
Okay, let me get the final answer. $35 out of 4. Yeah, that becomes value of Q.
Is there anyone that has found it challenging? Please give us any feedback in the chat. All right. Morgan says he's keeping on getting 27 out of 4. All right, so that's okay. That's okay. So let me now welcome any of your questions in this chapter as you prepare to tell me which other chapter I should go through for you. Hope these are the concepts people wanted. Yes, Ryan, give me your issue.
All right, teacher. My question is alpha and beta. Are you there, teacher?
Alpha and beta
are roots of the equation x
roots.
squared plus px are roots of the equation x squared plus px plus q is equal to 0. Express, open brackets, alpha,
express,
open brackets, alpha minus beta squared, close the brackets, then open other brackets, beta minus alpha squared in terms of P and Q.
This is beta minus alpha squared. This is alpha minus beta squared. The first one.
Yes, in terms, yeah.
The first one
in terms
is
of
alpha.
P and Q. The first one is alpha minus beta squared. Then close and then open again, beta minus alpha squared.
In terms of P
and Q.
And Q.
Then full stop, hence, there is a hence part.
Hence
deduce that.
Hence deduce that.
Deduce that for one root to be the square of the other, for one root to be a square of the other, yes. Hello.
I'm hearing. Proceed.
Hence, deduce that for one root to be the square of the other, p cubed minus 3pq p cubed minus 3pq plus q squared plus 2 is equal to 0. P cubed minus 3pq plus 2 squared plus q is equal to 0 must hold.
Must hold.
Yeah.
Okay. Has everyone taken note of that question? Okay. So from that equation, which is alpha x squared plus px plus q is equal to 0. If you let the roots have been told to us they are alpha and beta, so the sum of the roots will be negative p and the product of the roots will be q, will be equal to q. Now the expression you want to simplify is alpha minus beta squared into beta minus alpha squared. When you try to expand alpha multiplied into beta minus alpha squared minus beta squared into beta minus alpha squared, that leaves me with the alpha beta minus alpha cubed minus beta cubed plus beta squared alpha squared. So this will be alpha beta minus alpha cubed plus beta cubed plus beta alpha all square. So, but this quantity alone, alpha cubed plus beta cubed, how do we express it? Can someone tell me how we write it in terms of the sum and product? If you don't have a clue, you recall a perfect cube. Yes. Yes. Let me hear from Natural Truth. Please unmute.
Good evening, sir.
Good evening. How are you?
So it will be alpha plus beta. Bracket minus 3 alpha beta into bracket alpha plus beta.
So that would be the statement in terms of alpha, beta, and alpha plus beta. So alpha beta is q into the sum, which is negative p, all cubed, minus 3 times alpha beta, which is q, times alpha plus beta, which is negative p, plus alpha beta, which is q, all squared. And that leaves us with a q there, minus negative p cubed plus 3pq plus q squared. So that is q minus actually plus p cubed minus 3pq plus q squared. And that leaves us with the statement the statement that this person is actually asking. So this is the statement P cubed minus 3PQ plus Q plus Q squared, which has come from alpha minus beta squared multiplied by beta minus alpha squared. And then proceedingly, they ask us to see in a situation where if one root is a square of the other, for one root to be a square of the other, for one root to be a square of the other, then alpha will equal to beta squared, or beta will equal to alpha squared, which means alpha minus beta squared will equal to 0, or beta minus alpha squared will also be equal to 0, which implies that alpha minus beta squared multiplied by beta minus alpha squared must also be equal to 0 if those upper differences are equal to 0. Yet, this statement here is what we have just got. So when you feed it there, you would have proved what they wanted. Hope the person who sent that one is sorted. Yes, Victoria, unmute.
Teacher, sorry, I wanted to give an answer the other time when you're asking some questions.
Okay, it's okay. Yes, Ryan, hope your question is sorted.
Yeah, it is sorted, but this last part of hence, I don't know, have you let new roots or you still use the roots that you were given up?
They are the very roots that were given alpha and beta. Alpha and beta. I just connect them to this step here. I create these terms. How do these two terms come about? Alpha being a square of beta, or beta being a square of alpha. One root is a square of the other. Bring beta this way, squared. You will have alpha minus beta squared equal to 0. Bring alpha squared this side, you get beta minus alpha squared being equal to 0. So the product is also now equal to 0. And when you feed in those statements there, you're there. Is it okay? All right, that's it. So for the interest of time, we are pausing it here. However, we will handle a question like this one. We will handle a question like this one. Someone has asked for these types of cases. If equations bear to have a common root, if questions bear happen to have a common root, how would you deal with it like that one? Everyone take a note and go through those. When we come back, there will be our basis of discussion. If equations happen to share a common root, how do you go about that? I think it's someone's interest there. If equations bear a common root, how do we handle that? So the registration link, once again, it's here. Some people want it. All right, we are closing. Then here is the registration link, and we are posing it here. Take note of those details. All right. Okay. Can I have one of us close this discussion session today? Possibly someone who was not involved at the beginning. A boy this time. Can we have a boy? Close it up. Yes, Ryan. Please unmute.
All right, thank you, teacher, for the lesson. We are so much appreciative. Let us humble ourselves and we conclude. Mighty Father, we thank you. We give you glory, lift up your name. Thank you, Lord God Almighty, for enabling us to come to the climax of this Zoom lesson. We ask you to bless our teacher, Mr. Senyondo, for all that he has done for us. We ask you to enable us understand and grasp all that you have been taught, and may your glory be brought back to you. Make my prayer through Christ our Lord. Amen.
Amen. Bye-bye.